Hey guys, sorry, my last video cut off, so I'm going to finish these last two tabs on database functions and loan amortization tables. Database functions are pretty cool. They keep you from having to filter data and still be able to find some answers. So here we're going to provide the requested data using database functions. Note the validation drop boxes located in L2 and N2 for your convenience so that we could change them back and forth. More on how to make these later. We'll still learn how to make validation lists at some other point. So here we're going to calculate the sum of salaries and the average of salaries and so on and so forth. I'm going to update these to say sum of salaries so it's more clear before I give you this file, so bear with me there. So we're going to talk about database functions really briefly because they're cool, but we can do the same kind of thing with pivot tables and same kind of thing with sum if and average if statements. So we'll learn this way and then a couple of other ways as we move forward. So here dsum is going to be a database sum function. And I'll show you how this works. There are only 3 arguments in these database functions, and they're really kind of neat. The first one is database. So for the database function, you're going to select all of the data that is over on this side, A1 to I-742. I know that's a lot of data, but we're just going to go ahead and select it all, capture it all. I hit Command-Shift-Down. Control-Shift-Down works to get all the way to the bottom of that. It's really useful. Then we're going to select the field. The field argument in this is which field of this database do you want me to do my calculation from. For most of these, it's going to be salary, so we'll just click on the salary heading over here in the database. Now, it's important to click on this column title inside the database that matches something that you have over here in your database function. You want to make sure you click inside the database and select salary. If you select it over here, it gets a little wonky. Make sure you select it inside the database. And then we're going to figure out our criteria. So it says calculate the sum of all employee salaries in the IT department. So our criteria is going to be that the department name is IT. So over here in these headers that we've taken out and created these database functions, we'll select department and IT. Close our parentheses and hit enter, and that will give us the sum of all of the IT people's salaries. So that's pretty neat. Also, again, we could use a pivot table or a sum if, but we're just going to learn these first. So D average, database average. So database average works the same way. We will take the whole database. Our next argument will be field. Again, we're going to average salaries, so we'll click on F1 to note the salary field is where we want to get the data that we're actually going to average. And the criteria this time will be all the full-time people. So we'll select status and full-time over here from our criteria rows. We'll close parentheses again and be off and running. I'm going to go ahead and format all of these yellow cells to be dollars so it starts to make sense as we move through these. Please calculate how many employees have salaries over 70,000. So again, we will use database count and we will select all of the data, Command-Shift-Down, all of the data in our database. Here we want to know how many employees have salaries over 70,000. So again, our field is going to be salary that we're doing this calculation in, and our criteria this time is going to be salary greater than 70,000. Well, I haven't typed greater than 70,000 in here yet, but we can go ahead and select salary and the box below it and close our parentheses and hit enter. Right now, it's calculating the average salaries that are blank at this current moment, but that's not what we want. We want the average salaries over $70,000. I'm sorry, it wasn't averaging, it was counting them. So if I hit Command Z and go back, there are 741 salaries. If you click on the salary column, you'll notice here at the bottom there's 742 rows. And that's the number of rows including the column header. So now I want the count of salaries greater than 70,000. I'll type greater than 70,000 in this box, and I just get a count now of how many salaries there are over 70,000. So that's pretty cool. Dmax is going to give us the maximum salary, and we want the maximum salary for all full-time employees. So again, database, we'll select all of that data. We will select the field, which again is going to be salary because we want the maximum salary. And we want the employee status to be full-time. So we'll select just those 2 boxes. N1, it's going crazy on me, guys, sorry. N1, N2, here we go. You've entered, oh, I messed it all up. Okay, so I forgot now I need my salary field. I forgot to hit comma is what happened. So the database, the field is going to be F1. The status is going to be full-time, just like that. DMIN is going to be the same way. Database minimum of this same database. Shift down. Make sure I push comma this time to grab my salary field, and comma again to say the minimum of the full-time employee salaries. And now I have count A. So please calculate how many full-time employees have benefits. This one's important. It's not going to count the number of values, going to count the non-blank cells, which is important. There are 483, if I click on column D, 483 values here. Not values, values are numbers, so, but 483 entries here that are non-blank. So that includes the benefits. There'll be 482 employees that have benefits, but I only want to know the full-time employees that have benefits. So this is how I get this. So D count A, again, database in its entirety. Not sure what just happened there. But I'll start at the bottom since I'm at the bottom now. Command Shift up. Comma, field, and this time I want benefits, field, and I want to know how many full-time students. So my criteria is going to be status full-time, have benefits, and it's 380. So of these 482, 380 of them are full-time. So that's just a different way that you can do that instead of a sum if function. So hopefully that makes sense. Lastly, we have loan amortization table that we have to do. Up until now, we've done payments, we've done interest, we've done a variety of things with payments, but we haven't done a true loan amortization table. So now we're going to take that on. So here it wants us to calculate the payment based on this information up here. So we have an interest rate. We know it needs to be divided by 12. We know it's over 1. We know it's an annual rate. I'll put APR up here for you as well. The number of payments are going to be 24. This is a 2-year note. And the present value of this loan is $350,000. We're going to make sure that we put this negative sign out here and come up with our $16,191 payment. So if you're going to pay this $350,000 house off in 2 years, your monthly payment is $16,000. To calculate the interest, the formula is IPMT. So again, we're going to have the rate. We're always going to use this rate. We're going to drag this down, this entire loan amortization column. So we're going to freeze this rate here. So function F4. And we're going to remember that that's an annual rate. So we're going to divide it by 12. We're going to, PER is the period number, the number of period that we are currently in. That happens to be period 1 in the cell that we're typing in. The number of payments is 24, which is going to stay the same as we go down this column, so we'll absolute reference it. The present value is also going to stay the same for this entirety of this loan. The present value will have started at $350,000, so we will lock that one in as well. It's not going to make sense to some of the students that the present value is locked in because the present value is going to change. But the interest payment calculation, because it's taking into account the period, is doing that math for us. So if we were doing the math ourselves, we would be basing it off remaining principal. Since we're letting Excel do the work for us, we will base it off the present value. We will lock that in, and again, all of this comes back as negative, so we will make it a positive, copy it down as we go. This is the interest payment. The interest portion of all of those payments. Now we want to find out the principal portion of all those payments, and that would be PPMT. Principal payment. Again, it's the same argument, so I'll do it faster for you. We'll lock down rate, divide it by 12. Our period number, again, is going to be 1, which is going to change as we drag it down, so we won't absolute reference it. The number of periods is always going to be 24, and the present value is always going to be 350. So we'll lock those down as we go down as well. Again, I can't for the life of me remember that negative sign, but there we have. So the way that you check your work here is, and the whole reason we have this payment calculation here is so I can make sure that my payments total $16,191.14 all the way down. They do, in fact, and that is my payment. So that's the interest portion of my payment and the principal portion of my payment. Now we have total interest and total principal paid. These are different formulas. This one is cumulative interest. C-U-M-I-P-N-T, I think. Yeah. Cumulative interest payment. So again, we have a rate. It's always going to stay the same. It's always going to be divided by 12. We have a number of periods, which is always going to be 24. We have a present value, which is always going to be 350. We have a start period, which is going to be 1. And we have an end period, which is going to be 24. And we're going to say, nope, you've entered, what have I done? You've entered too few arguments for this function. Okay, which one did I leave off? Rate, number of payments, present value, start period, end period, type, 0. Nope. All right, hold on a second. So what have I messed up? Let's think about this for a second. So what have I done? So I want to make sure. Oh, I messed these up. Sorry. Okay. So bear with me. This is a very complicated formula. So we'll go back and we'll start over and I'll walk you through it again. So cumulative interest payment, we have rate, which is always going to be here. It is going to be locked in and divided by 12. Our number of periods are, in fact, always going to be 24. So far, so good. Our present value is going to be 350,000. These are the easy arguments. The ones that don't make a lot of sense, start period and end period. And it's not going to be 1 and 24. I don't know what I was thinking. It would be if we were way down here. But our start period is going to be 1. All the time. Our start period is forever going to be 1, so we will lock in the start period here. Our end period for this particular row is also going to be 1. But as we go down, for cumulative interest, our start period is 1, and if we're down here in row 12, our end period will be 12. Right now it is also still in 1, so we will do end period again as the same row, but we won't absolute reference it. We'll let it move as it moves down. And then our type, just for the purposes of this class, is going to be 0. It's annuity due, so that's fine. It's the same argument that we used before. We'll copy that all the way down and get our interest total here at the bottom. So the total interest paid, it says, is going to be $38,587. If we highlight this whole interest column, we see a number that matches, so we can check our work there. Now, let's see if I've lost my mind again. Cumulative principal payment. Cumulative P-R-I-N-C. I can't remember these and my Mac doesn't bring it up. So cumulative principal, C-U-M-P-R-I-N-C, is going to be rate, absolute reference, divided by 12. It's going to be number of periods, absolute referenced. It's going to be present value, absolute referenced. It's going to be the start period, which is always going to be 1, so absolute reference. It's going to be the ending period, and this row again is row 1. And a standard loan, again, not going to be negative if I don't take that, put that negative sign out there. So your total principal paid should again go to $350,000. The remaining principal is just the present value minus the principal paid in this row. So you'll notice $350,000 minus the principal paid in that row is that. But as we go down, it's going to be the row above it minus the principal paid. Oh, no, remaining principal if we want to move it that way. We can lock down B5, absolute reference B5, and say the total present value of the loan minus the principal that we've paid should go to 0. So here we have $350,000 minus the cumulative principal, so that's how we calculate that. The other way that I was trying to do it was to take the remaining principal minus the principal payment, but that would have been over here and is less complicated to think about it with the absolute reference here. So have the students do it that way. Again, always more than one way to get to the answer, but we're trying to just get them used to loan amortization tables. So you guys know these from accounting. These are important, but people will be doing them in a variety of different fields. So I hope that helps. Let me know if you have questions.